Go ahead and have a seat. So yesterday was kind of a disaster. So we're just going to modify yesterday's lesson, and then we're just going to keep it moving with what we have to do today, just because I don't like to harp on a bad thing, and I feel like yesterday was kind of a bad thing, so let's not do that again. So on the handout that you did receive yesterday, I need you to flip to the back page. So 3.3 off the grid. And it says, find the area of the shaded regions of each figure. Explain or show your reasoning. So the way we're going to explain is just by using numbers. So this first one, number 1, what shape is that? Raise your hand. What shape is that? Delilah. It's a parallelogram, right? So if we're using the formula, remember, area equals base times height. We can use the formula that way to find the area of this shape. Or what is another way that we could take this shape and turn it into a shape that we already know the formula for? Cooper?
You take the bottom half of it and transfer it up on top to make it vertical.
Right, so we can take this bottom piece and then bring it up here, and we have 3 centimeters by 5 centimeters. What shape is that? If I take this bottom piece off, what shape did we just make? Rectangle. So the formula for that one is length times width. So essentially you're doing the same thing, right? So then what is 3 times 5?
15.
Oops. 3 times 5 equals 15 what? Centimeters squared. All right, so that is the answer for that first one. All right, now let's look at this next one. We're finding the shaded region, which means the dark part. Now, we're not going to use the formula of a triangle. What can we do, though, that's similar to what we did in A? What can we do for this one? Mikhail? Got to speak up a little bit. Well, we're not trying to find the area of the whole shape, right? Just the shaded part. So essentially, just our shaded parts are in what shape? They're in triangles. Well, guys, what did we learn about 2 days ago? Where we had the square, and we had lots of small, medium, and large triangles. What did we learn about triangles? Ethan?
You can put 2 triangles together to make a square.
Or a,
Parallel.
which is also a,
Rectangle.
yes. All right, so if we take and I move this triangle here, what do I make? A rectangle. All right, and if I take this triangle and move it here, what do I make?
A rectangle.
So I make 2 identical rectangles. So our length and our width is 4 times 2, which gives us what? 8 what? Yeah, right over there? Do you need to go get some water? Nope. If you need, go ahead, babe. 8 centimeters squared. But how many rectangles did we make? 1 or 2?
2.
So what do we have to do with our answer then? By 2. So this actually becomes times 2, which is 16 centimeters squared for the answer for that one. So this whole lesson essentially was just about decomposing and rearranging. All right, and I feel like we do understand that, you know, you can cut this piece off and put it into a shape that we do know the formula for, or we do know how to solve. All right, this last one could be a little bit harder if you think too hard. So remember, we're finding the shaded region. So what is the total of our square? Like, what's the total of the outside of our square? I need someone other than these 3. Or let me rephrase my question to make it a little less intimidating. What's the length of all the sides on the outside of our square? Cristiano? 5. Right. So if it's a square, we know we do length times width as well. So let's start with that. So 5 times 5, which gives me what? 25 centimeters squared. All right. Now, is that my answer?
No.
Why not? Raise your hand and tell me why that's not my answer. Delilah? Right. So the inside shape, if I look at this inside shape, what do I notice about the two sides that they give me? What's the same about those two lengths of sides? Kylie? So that tells me that that is also a square, right? So then I'm going to do 2 times 2, which gives me what? So 4 centimeters squared. So which one of these is my answer? The 25 or the 4? Ronnie? Nope. Noah? Why? You are right. Neither one of those are my answer. What do I actually have to do with 25 and 4? Noah, do you know? Yes. Yep. So 21 centimeters squared is the total area of the shaded part. Shaded part. Does that make sense? All right. So again, I didn't want to completely walk away from this lesson, but I feel like let's not beat a dead horse. Let's just kind of have this as our warm-up, and then we're going to keep going. There will be no cool down for this lesson. So just put an X on your cool down page, and then turn the page and get out this page. So this is where we're starting today. Shh. We do not need to have conversation. Yes, ma'am? Yes. Yeah. But I didn't feel comfortable assessing you guys on yesterday because it went so bad. So, you know, sometimes you just gotta chalk it up as it is what it is. Okay, so it says, I'll wait for all the noises to stop. It says figures A, B, and C are parallelograms. Figures D, E, and F are not parallelograms. So you have 3 questions that you are going to be answering. It says study the examples and non-examples. What do you notice about 1, the number of sides that a parallelogram has, 2, the opposite sides of a parallelogram, and 3, the opposite angles of a parallelogram. So I'm going to give you 2 minutes. Answer these questions, and then we'll go over them excuse me, together. With your answers? They shouldn't be. Did you answer these already? Opposite sides of a parallelogram. Opposite sides. What do you notice about? you're finished. Stop touching people. All right, go ahead, have a seat. So, what do you notice about the number of sides of a parallelogram? So, what do we notice about A, B, and C? They all have what? Ronnie?
They are 4 sides.
Okay. What about the opposite sides of a parallelogram? So this side and this side. This side and this side. This side and this side. This side, this side, this side, this side. What do we notice about them? Aiden.
They're parallel.
Okay. Do you notice anything else about the opposite sides? Hello?
Some of them are even.
Some of them are even, or they are
Are.
all?
They all are even.
Opposite sides. So like this side to this side, are they even?
Well, yes, but like for the rectangle, they're.
It's not a rectangle though. And we're only talking about the opposite sides, right? So technically the opposite sides have to be equal or the same. Because if one's longer or shorter, then is it a parallelogram? Okay, so let's add that as well. So they are parallel and equal size. And then the last one is opposite angles of a parallelogram. What do we notice about the opposite angles? So like this angle and this angle. This angle and this angle. What do we notice about them? Cooper?
You can all make sort of like a shape when you connect the angles. Like I was actually kind of testing that out. I made like lines through it, and from this angle, you can make like, I don't know, I can't really explain it.
So give me a very simple explanation. They're what? So like this side, Cooper, so this angle right here and this angle right here, what do you notice about them? They are what?
They are the same size.
Right, they're equal or the same size.
It's like kind of trying to say that.
You said you over there drawing shapes.
Yeah, I was like, we're not drawing shapes.
You said shapes.
Connecting the angles.
Okay, I'm still confused. You trying to be rocket science. We just need
So
simple
everyone
notes.
wants to lost.
I know.
All right, slide over to the next part. So we are going to find the area of each parallelogram. Belle, if you can't sit there without talking, because that's the second time, you need to move. As your last warning, also will be silent lunch today. Now, which side is our base? So let's look at this first one. Which side is the base? Troy? Or, right, so the bottom or the top. It doesn't matter which one you identify as your base, as long as it's the top or the bottom. So I'm just gonna put this up here. You can put yours on the bottom. I do not care because we're gonna get the same answer, right? All right, so what is the base equal to? How do we figure that out? How do we figure that out? Cooper?
It's how many, so,
Right now, we're just simply asking, what is the measure of our base? What's the measure of our base? Camden.
However many squares there are.
Right. So I'm going to do 1, 2, 3, 4, 5, 6. So the base equals 6. Now, I want you to come up with a strategy to find the height. Whether you decompose, rearrange, use the formula, doesn't really matter. Okay? As soon as you have done that, go ahead and stand up for me. Question. All right, so have a seat. How many of you guys decomposed and rearranged? Okay, how many of you guys used the formula? And that's fine. Either way, because those are two strategies, you can do one or the other. So if you decide to decompose and rearrange, you essentially should cut it here, move this piece over here. If I could draw an arrow, that'd be fantastic. And then this becomes your new shape. So that new shape, how do we figure out what it is? Troy?
You know it's a square because they have the same base and height.
Excuse me, so you have to then count this side, right? So 1, 2, 3, 4, 5, 6. So your height equals 6. So yes, you are correct. We know that it is now a square because it has the same base and the height. So from here, we just do 6 times 6, which gives us 36 units squared. All right, how many of you guys, you said you used the formula? Okay, did you identify the base as like right here? Or I'm sorry, the height is right there? Or on the other side where I drew my line? This one? Okay, and you did, so once you identified that as the height, did you just count that? And then you got 6, which gives you the same thing. All right, so either way, ladies and gentlemen, I don't care which one you use. Sometimes identifying the base and the height and doing it that way will work. Sometimes cutting it, decomposing it, rearranging it will work. Okay? So now I want you to find the area of this parallelogram. Stand up when you have your answer. Jonathan, what's the problem today, son? If you're standing, are you supposed to be talking? Please stop. All right. How many of you guys decomposed? Okay. How many of you guys used the formula? Perfect. All right, have a seat. Now, I'm a little bit confused as I'm looking at this shape. Because the last one, I felt like it was super easy. You know, you cut it here, you move it there. But this one, like, I'm not exactly sure where to cut it. Where do I cut it, Mikhail?
So you put it down the middle and then the other
So I'm going to cut it right down here? Like in between this corner and this corner? Nope. Nope. Don't cut it down the middle.
You cut it off at the corner at the bottom, the first corner.
So this one?
Yes.
Okay, so I'm going to cut it here, which means I'm going to move this whole piece around here. So I got to do 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Bring it up and add it. Okay? You can't cut it down the middle because then you're dealing with half squares, which, I mean, essentially you should say, okay, well, even if I cut it down the middle, it's going to be a half square here and a half square here. But the likelihood of us knowing that we have to add this extra little side here or a half of this side gets a little complicated. All right, so when we do that, what is our base? What's our base, Ronnie?
7.
What?
7.
1, 2, 3, 4, 5, 6. Count it again. Guys, gotta be careful.
6.
Okay. So our base equals 6. What is our height equal, Mikhail? And then we end up doing 6 times 3, which gives us 18 units squared. For me, this is one where using the formula might be a little bit easier just because it's not this is not a super nice parallelogram. And if you did that, just identifying, this is where you can identify the height in the middle of those two. So you could do 1, 2, 3, make a little, what's it called? Height indicator. Our base is still 6 and our height is still 3. So either way will work. And if you divided it, like if you identified the height over here, that's fine. If you identified it over here, that's fine as well. As long as it is perpendicular to the base, that is all that matters. All right, let's slide down to the next part. So we're finding some more area. All right, I want you to find the area of both A and B. Now stop and put your pencils down so I know you're listening. You must use a different strategy for both of them. So like one strategy can be the formula, the other strategy must be decompose, rearrange. Okay? So you cannot use the same strategy to solve both A and B. Does that make sense? All right, stand up when you have your answer. I'm gonna set the timer for 5 minutes. Yeah, work, son. Work. Do work. You sitting there staring at your paper. If you do not remember the formula, you can always look back at our flip book. I see a couple people have done that, and that's fantastic. That's why it's in there. Guys got 15 seconds. Alright, so how many of you guys decomposed and rearranged the first one?
No.
Okay. Alright, how many of you guys used the formula? Alright, so for this one I'm going to decompose it. I'm going to cut it here.
I know.
I'm going to rearrange it right here and make what kind of shape? Rectangle, so I'm going to do 1, 2, 3, wait, 1, 2, 3, 4, 5. So my height is going to be 5, my base is going to be 3, and then I'm going to do 5 times 3, which gives me 15 units squared. Why do you think I decomposed this one, since I had to use a different strategy for the next one? How many of you guys tried to decompose that one and it got real hard? This one. That was really hard to decompose.
I erased it and restarted.
So with this one, I highly recommend using that formula. And your height is actually here.
Oh,
Because remember, it just has to be perpendicular to your base. So you are allowed to extend the height out from the shape. And that's something we're going to be talking about tomorrow. So then when I count my height, it's 1, 2, 3, 4, 5, 6. And then my base is only the shape part. It's not all of this. Does that make sense?
I got
Okay.
two.
So your base is going to be 2. And then you just simply do 6 times 2 equals 12 units squared. Okay? So this is why it's good to have a couple different strategies to know and hopefully understand a little bit, because this one's super easy to decompose, right? I mean, at least I feel like this one is easier to decompose than that one.
Yeah, I do.
Yes,
On the first page, it actually tells you how to decompose it.
that's not the first page, that's the last page, but that is part of our summary, yes. All right, so regardless of which strategy you used on which one, did we all get 15 units squared for the first one?
Yes.
And do we hopefully get 12 units squared for the second one?
Yes.
All right, let's flip it over. C is the last one. So now what do you notice about C? What does it not have that the first 8, I feel like, that we talked about have had, sorry, I can't speak, Delilah? Doesn't have any squares, so now we can't count at all, right? So that's why counting was not even an option. I didn't even give it to you, I didn't even remind you. Because I don't want you to get stuck on counting. Now, we have 3 numbers. What do we do? Because we have 3 numbers. What do we do? Are we finding volume? What are we finding?
Area.
We're still finding the area of a parallelogram, right?
Yeah.
So we're either using the formula base times height or we're decomposing and rearranging. Mikhail, what do you want to do? Hold on, I can't. Okay, nice and loud. You want to use the formula? Okay, so if I want to use the formula, like Mikhail wants to use the formula, Mikhail, am I using the 4, the 6, or the 4.5? Because we have 3 numbers, right? How do we know which ones we're using for our formula? Because our formula is base times height. So that's our formula. Yep, go ahead. I can't hear you, babe.
You said that the base would be 6 for the bottom
Easy. So which one do we use? The 4 or the 4.5? No. And why do we not use the 4.5? What is that 4.5? It is what kind of line? What kind of line is that 4.5? It's a diagonal line. Everyone, take a second. Go back in here and let's get a parallelogram. What did we write? Why do you think they put that 4.5 on that problem? Yep. And it would have worked, right?
Yep.
Some of us it would have worked. All right, so this number is, that number is strictly there to confuse you, to make you think, I don't know which one to use, so I'm just going to guess. But your height for this one is going to be the 4. So we're going to do 6 times 4, which gives us what?
24.
Not just 24. Units squared. I do want to show the decompose rearrange. So you would cut it right here, move it over here, and add it there. And that also helps you eliminate what line?
The 4.
The 4.5. Because now it's in the middle of your shape and you know for sure that you are not going to be using a number in the middle of your shape per se. Alright, but either way, whether you do decomposing or using the formula, it doesn't matter. And that is it for our lesson for today. So go ahead and fold it in half. Bless you. Listen guys, you are gluing the back side, this side right here, and you're gluing it down on this page. Why are we talking? Stop, please. All right, on your cool down today, it is asking you to obviously find the area of the parallelogram, but then it also asks you to describe your strategy. If you do not explain the strategy that you picked, you will get this question wrong. All right, we talked about 2 different strategies today. Raise your hand and tell me what was one. Floyd, the formula, which was what? Base times height. And then what was the other strategy that we used today, Delilah? Decomposing and rearranging. Alright, please turn in your cool down when you are finished. After you are done, you are working on either benchmark if you haven't finished it yet, or you're getting on Imagine Math and working on lessons.